potential for students to be involved in future orbital missions like this one?
Yep. Let's see. Would you like to answer that, or I could?
Well, I think that both of us could very easily answer that, so
Yeah.
I'll piggyback if you don't finish up.
I'll give it a shot. So there are several education opportunities through the National Laboratory effort. The one that is headed up into orbit tomorrow is known as the INSESI, Student Spaceflight Experiments Program. And so that's the the National Center for Earth and Space Science Education. Thank you. So if you go to ssep.ncesse.org, because I knew someone would ask me that, I had to write it down. You can go and find out. They put out calls for student participation in space station science experiments via what's known as the NanoRacks effort. So they'll put, let's see, what's going up tomorrow, I think, is 23 individual student experiments in tiny little tubes called mixed sticks. And they were all student ideas that were submitted via student proposals. So it's grades 5 through 12 that's represented, and these students actually wrote proposals for what they wanted to do, complete with a hypothesis, the methods, and what they expect out of their research. And the 23 investigations are actually going to represent something like over almost 9,000 students on the ground in terms of participation. And in fact, I think the program received almost 2,000 applications from students. So that is a very robust ongoing program that happens through the National Laboratory effort, through CASIS, that I don't see going away anytime soon. And there are opportunities through companies like BioServe, who reach out through BioEd Online for student participation. There are actually several astronauts, when they fly, have a strong interest in outreach and education plans for their stay on orbit. So we meet with them beforehand and coordinate with them on what they'd like to see in terms of offering opportunities for students in education, demonstrations on orbit. So there's a lot of demonstrations that happen that explain the changes in microgravity and some of the cool things that we see in science with regard to that in terms of demonstrations. I believe there's also EarthCam, which is a camera that allows students to sign up through their middle schools. You go online, it's Sally Ride EarthCam, and you can participate in taking images of the Earth from the space station by assigning coordinates and locations that you like to see. And so there are several opportunities throughout the year for that for students as well. I think the CASIS effort is opening up a huge opportunity for students, and launches like Orbital give us more upmass to be able to meet those needs.
Other questions?
Yeah, another question here comes from Twitter user Kaylee. How will the sphere slosh experiment improve future rocket launches, and why is microgravity slosh important?
Okay, so the slosh experiment is really cool. Someone's doing their research. So on orbit, we have these little satellites known as spheres. Of course, it's an acronym, but basically these tiny little satellites, about this big, there are 3 of them, and they run on carbon dioxide propulsion, and you can communicate with them via algorithms that you can program from the ground. And the point of them originally is to try different algorithms to test out formation flying so that you can look at improvements in automatic docking or satellite control and things that help us in space with autonomous vehicles. But we have applied it to educational use as well. And so we have students that participate in design competitions around the world a couple times a year. So that's another student investigation that's participatory. But the slosh investigation is going to actually modify, one of these sphere satellites is going to be modified with a fitting that can hold fluid inside of it. And we know from lots of models that have been, or lots of investigations that have created models on fluid behavior on the space station, we know that fluids behave differently. They prefer capillary flow. They like to climb the walls and hide in corners and don't behave as it would here on the ground. And so this particular investigation is going to use a sphere satellite to program its movement, and then we'll be able to watch changes in the fluid sloshing around and how fluid would behave in a moving vehicle, so to speak, or a moving container, which we haven't done before. So this is new, and it's pretty cool. It's going to give us new models by which we can learn more about fluid behavior. It's important for spaceflight, of course, for obvious reasons. We're talking about creating any kind of fluid container, whether it's propellant or water. You name it, it's all critical and it's applicable to understanding fluid flow.
Let's go back here to the audience. Any hands? In the back?
Unless chemistry teachers in space, we have an experiment flying tomorrow with SSMP. We've also
One sec, I think the microphone may be off. Let's try it again. You have an experiment flying to,
yeah.
experiment flying tomorrow. Go ahead, I'll relay.
Yes. And meanwhile, we've also been teaching teachers to work with Arduino sensors and doing balloon launches. We're very interested in what NanoSatisfy is up to. And I'm curious whether NanoSatisfy is doing anything with suborbital, with X-core or Virgin or even Maston, because we'd love to start building that bridge from balloons to suborbital and then also orbital.
So the question is, how is NanoSatisfy doing? Is NanoSatisfy doing anything suborbitally?
Yeah, we actually don't do anything suborbital or with high altitude balloon flights. We feel there is like a very, very active community already out there which does high altitude balloon flights. Suborbital, in our feeling, it's right now actually easier to get access to space through the ISS and through those programs than it actually is possible to get access to suborbital. The other problem with suborbital is that it's severely time limited. Like the satellites that you saw in that picture beforehand, they're going to be up there for 10 months. This is going to be up there for a year, right? So 1 year, that gives like literally tens of thousands of students a possibility to interact with it and do experiments and interact with the sensors, which is much, much harder to do on a suborbital flight, where right now the launch vehicles are actually not available. They will become available, but it's actually not there. So we don't do suborbital, we don't do high altitude balloon flights. Our curriculum, however, is just as applicable. And the sensor packages that we have are just as applicable. And we have considered taking our sensor package that we put onto the satellite and work with people who want to use the same sensor package, which is Arduino based, and we have put together to use it for suborbital or for high altitude balloon flights.
Tony, if we have questions on the phone line, I'm happy to go ahead and take the first one. If not, we'll go ahead and come back here to the audience. Okay, any additional questions here? Show of hands. Let's take one from social media, if we have a live mic. If not, just say it loudly. Microphone's coming to you, Jason.
This comes from Twitter user Ramix. How long will it take for results of experiments to be made public?
Okay, good question. So in a regular ground functioning laboratory, you can start an experiment and not publish until 3 to 5 years out, because that's what science is. It takes time, right? It's not just one and done. It's usually repetitive, because you want to validate the science that you found, you want to validate your results, and then come to a reasonable conclusion before you publish anything. That has actually been the rate that we've seen for station already so far. So we're still getting results from investigations that occurred in the early assembly phase of space station. And to date, we've received over 600 publications that have been published in peer review. So on average, I guess that's a long answer to what should have been a short one. On average, it's about 3 to 5 years from the start.
Wonderful. This Twitter question comes from Marcia Smith. Where does the money for the CASIS experiments come from? Is it 100% non-government? Who does pay?
So the way that the CASIS has been structured is we are a not-for-profit organization. However, we do receive every year $15 million a year from NASA as far as seed money is concerned. Right now, most of the projects that are going up under the CASIS manifest have been either brokered through that seed funding money. However, we are starting to morph into a more partnership model where we are working with organizations that might be able to do matching dollars or things of that nature. Additionally, we also work with a lot of companies that in some instances they don't need any additional funding, that they can fund their own experiments. So it really does vary depending upon how it is we interact with companies and the types of funds that are necessary for them to get their research to the ISS.
Okay, I think that's going to wrap us up. If you weren't able to get a question in, just please tweet at us using the hashtag AskNASA. We'll get you a response as soon as possible. As a reminder, you can find out more information about all the science that's headed up on the Orbital 1 mission as well as the mission itself at www.nasa.gov/station. Please stay tuned to NASA TV for the next hour. We'll have a look ahead to the mission, a preview of tomorrow's 1:32 p.m. launch, as well as a weather report, which may be cold, but I hear it's looking good. Please help me thank our panelists, if you would. Thank you all for joining, and we'll see you again in a few.